Good night, everyone. Welcome to another episode. And we're going to be, again, focusing on some math practice. Pardon me. Now, it's important for us to work on our mathematics as our diagnostic results showed that we need to really focus on getting better scores. So let's start. Here we have a question. 1,805 plus 25 plus 52. Let me see if I can bring my cursor in. Okay, so I'd say 5 and 5, 10, 10 and 2 would give me 12. I'm going to write 2 and carry 1. I'm going to say 5 and 2, 7, 7 and 1, 8. Bring my 8 down and bring my 1 down. So 1,805 plus 52 should give me 1,882. Here we have a dollars and cents question. What will be the total if we add $19.13, $3.25, $1.10, and 3 cents? So we could just put placeholders here. So this is nice and neat. So 5, 3 and 5 would be 8, 8 and 3 would be 11. We're going to write 1 and carry 1. So we're going to say 1 and 2, 3, 3 and 1, 4, 4 and 1, 5. So we have a total of 51 cents here. Decimal point on the decimal point. So the 9 and the 1 would be 10. The 10 and the 3 would be 13. We're going to write 3 and we're going to carry 1. And 1 would make 2. So when we add $19.13 with $3.25 and $1.10 and 3 cents, we should get a total of $23.51. It says, what is 3/10 expressed as a decimal? So 3/10 as a decimal is, our answer should be 0.3. So this is a division problem. It's just set out vertically. So we could look at that horizontally as 3 being divided by 10. Let's fix up that 0. Okay. Let's see what this would look like if we were to set that out. The 3 would go inside and 10 would go outside. So the 3 is the dividend, while the 10 would be the divisor. Now 10 into 3, that can't work. We're going to add a decimal point and add 0. And 10 into 30, 3 times 3 tens rather, would give us 30. 30 from 30 would leave us with 0. And this is how we get our what? Or 0.3. Okay? So again, shortcut way of doing this. We have 3. We know that there's an unstated or unseen decimal point to the right of all whole numbers. So we have 1 0 here. So we're going to move to the left 1 place. So we use a placeholder to help us to see that decimal point. So we end up with 0.3. So this is how it's done. Choose the way that works best for you and make sure that you apply the concept correctly so we can get 0.3 as the answer. 3/4 as a percentage is. So 3/4, and once we hear percentage, we know that we're going to have to include what? 100. So we're going to multiply that fraction by 100 to see what it is as a percentage. Now, What's the highest common factor of 4 and 100? That would be 4. 4 can go into itself one time, and 4 could go into 125 times. Now we're left with a simple what? Multiplication problem. Numerator by numerator and denominator by denominator. So 3 sets of 25 would give you 75, and 1 by 1 would give you 1. Any number divided by 1 remains the same. So we end up with 75%. So 3/4 as a percentage is 75%. So in this particular question, they're just asking if you know how to represent a common fraction as a percentage. So 0.025 as a fraction is, and in this case, it should be 25 over 1,000. Okay. So how do we know that? We have 1, tenths, hundredths, thousands. Let's see if we could try this. 25. I will divide this by 1,000. Let's see. Now, 1,000 can't go into 25. 0. Add zeros here as necessary. So let's start with 0. 25 can't go into 250. Add 0. Add another 0. Add another 0 to continue. And 1,000 into 2,500 could go 2 whole times, and we get what? 2,000. We're going to subtract. We're going to be left with 500. 1,000 can't go into 500, so we're going to add another 0 to continue. And 1,000 can go into 5,000 5 times. 5 times 1,000 would give us 5,000. Subtract, we get 0. This is how we end up with what? 0.025. So the fraction, the original fraction, should be 25 being divided by 1,000. So that's what we have stated here. Okay, so as long as we're adding our zeros and keeping track of what we're doing, we should be able to change this decimal into a simple or a common fraction. Here we have a subtraction problem, decimal problem. So we have 23, and we're going to take away 0.23. So we put our placeholders in because this was a whole number, no expressed decimal. So we need to put that decimal point in and put our placeholders. Now I have 3 from 0. That can't work. So I need to take from the 3, leaving me with 2. Let me swap colors here. This gives me 1 here. Still not where I want it to be. So going through the steps all over again. Take 1, put it there. Now 3 from 10 will leave me with 7 because 7 and 3 makes 10. 2, we're done with this column, so we're going to move on. And 2 from 9 will leave me with 7 because 7 and 2 makes 9. Decimal point on the decimal point. I have nothing to subtract here. I have nothing to subtract here. So my answer is 22.77. So 23, when we take from 23 0.23, we end up with 22.77. If we wanted to test to see if this is correct, we could actually use a reverse operation. So what's the reverse of subtraction? It would be addition. So the answer I get here, the difference, I'm going to add to that to see. So let's go. We have 22.77, and I'm going to add a subtrahend. So we have 0.23. 7 and 3 would be 10. So I'm going to write 0, carry 1. 1 and 7, 8. 8 and 2 would be 10 again. I'm going to write 0. I'm going to carry 1. 2 and 1 would be 3. Bring our 2 down. Decimal point. So I end up with 23. Okay. So this proves that our answer here is correct. And it's very important that we're able to what? Check our answers. So we need to use the reverse operations to make sure that what we get is actually what it should be. What is the value of the 8 in this number? We have 2350 28. Okay, no decimal is there, so this number would be in my ones column. Then we have our tens, we have hundreds, we have thousands, we have tens of thousands, and hundreds of thousands. So let's go. I have 200,000, 3,000, so that would be two. No, this is tens of thousands, so this would be 30. So 230,000. I have 5 more thousand there. So this would be 235,000. No hundreds. 2 sets of tens would be 20 and 8 ones. So let me call all of this. This would be 235,028. Now what's the 8? The 8 would be in the ones or units column. So this would make what? 8 times 1, we know that is 8. So the true value of this is simply 8. So this question wants us to look at what is true value versus or place value and or face value. So we need to be able to make the distinction between all of those things. True value, place value, face value. Okay, next question. What are the factors of 32? So we have 32. What are the factors of 32? We were not asked for prime factors, so we can do our listing. So we'll say 1 and we'll write 32 and then we'll close this gap. So 2 could go into 32 how many times? 16 times. Could 3 go into 32? Not that I'm aware of, because if we add this 3 and 2, that would be 5. No, doesn't look like that. So let's try 4. 4 could go in there 8 times. Anything else? 5, 6. Can we think of anything else? So let's go with this now. So the factors of 32 would be 1, 2, 4, 8, 16, and 32. So 1 could go into 32 times. 2 could go into 32 16 times. 4 could go into 32 8 times. 8 could go in there 4 times. 16 could go in there 2 times. 32 can go into 32 1 time. Right? So we call this method the listing method. And it's important that we're able to find the factors when needed. All right. So 1, 2, 4, 8, 16, and 32 are factors of 32. So 2% expressed as a decimal. So 2%, we're going to convert this 2%. So the numerator would be 2, the denominator would be 100, and we need to put this in decimal form. So we're going to be moving that decimal point 2 places based on these zeros. So we go 1 place here add a placeholder and go again. So this should be equal to 0.02. Our answer is 0.02. So step one, convert your percentage like this into a common fraction. Look at it, and then make the movements necessary based on the rules, and we end up with the decimal. Okay. A number that has 1, 3, and 5 in the ones place is it always prime, odd, even, or composite? Now, think about this. Prime numbers only have two factors, one and itself. So if a number has 5, is it always prime? Let's think of 25. Factors of 25, 1, 5, 25. So this has more than one on itself. In fact, this is called a composite number. So this rules out prime. Okay. Is it always even? In fact, 1, 3, 5, 7, 9, these are odd numbers because they are not exactly divisible. Yeah, sorry about that. So they are not exactly divisible by 2. If they are divided by 2, they'll always have a remainder. Okay. So let's go with this again. So we know that they are not even, they are not prime, and a composite number has more than 2 factors, right? So 3 is not composite, so we can't use this, but we are certain that they are all odd. They are always odd. So any number that has 1, 3, 5, etc. in the ones place is always considered an odd number. Okay, which one is an infinite set? Now, a finite set has a what? A set of numbers that we can, it's a set that we can count, right? And it has a, let me say that again. A finite set has a definite number of elements in it. Okay, so we can count them and we can come up with something. Now, something that's infinite, we could count from now until Jesus comes. We will not finish counting. Okay, so it's very different. So the letters of the alphabet we know are 26 letters. Number of planets, we know that the number of planets are the number of planets in our solar system would be equal to 8. Highways in Jamaica, we could count that. But points on a line, we can't count. Okay. So this one would be the infinite set. Okay. So letters, we can come up with some cardinal number to show the number of letters in the alphabet. For the planets, we know that we have 8 now. We had 9 before, we had 8, right? And prior, and the points on the line would be infinite. Cursor is gone again. Hold, okay, it's back. So 85.37 rounded to the nearest 10. What would that be? So here we have 85. We're rounding to the nearest 10. So let's look for the 10 tens column. So this would be ones. Here So this is ones and this is tens. So we have two groups. We have a rounding up group and a rounding down group. If we have 5 or more, we round up. If we have 4 or less, we round down. So 5 is in our rounding up group. So we're going to add 1 to the number that we're rounding. So we'll add 1 to 8, making it 9. And we'll put 0 for the rest. What this really means is 85.37 is closer to 90 than it is to 80. Okay, so if we had 90 here and we had 80 here, as in the upper and the lower levels or bands, so to speak, this number 85.37 thereabout, okay, this is considered to be closer to 90 than to 80. All right, so 3, 7, 17, 19 are what type of numbers? We already know that these are not composite. They are not even. They are odd. Yes. They have the 3, the 7, the what? 17, the 9. We know that they're odd. But above that, the best description would be that they are prime. 3, only 1 on itself. 7, only 1 on itself. 17, only 1 and 17 as factors. 19, 1 and 19 as factors. So the best description for those numbers would be prime. Okay. What must be added to the product of 25 and 10 to make it 420? So first, let's deal with this side of the problem. So product of 25 and 10. So 25, and we're going to multiply that by 10. We just simply add the 0 here and continue. So 1 times 5 would be 5, and 1 times 2 would be 2. So 25 times 10 would give me 250. Now I need to know what I'm going to add to that to make it up to this. So one easy way to do this is to find the difference between these numbers. So let's take 25 from the 4, not 25, 250 from the 420, and we'll see what the difference is. So 0 from 0, 0. Now I can't take 5 from 2, so I'll take 1 from the 4, leaving that particular place with 3. And 5 from 12 would be 7, because 7 and 5 would be 12. And 2 from 3 would leave me with 1, because 1 and 2 makes 3. So the difference would be 170. Let's check this. So 25 times 10, going to work that out, and we're going to add to this 170, and we should get 420. All right. So this would be 250. We're working what's in the bracket first, and we're going to add to that 170, and we should get 420. So let's put this here. 250 plus the 170. We're going to add this 0 and 0, 0. 7 and 5 would make 12, right? 2 carry 1, and 1 and 2, 3, and 1, 4. So we end up with 420 being equal to 420. Once we work this down and we get both sides of our equation having the same value, then we know whatever we had plugged in or substituted or whatever we're working towards is now correct, because it is balanced. Okay. Let's see if we could work this out. We have 2 and 4/5 plus 1 and 2/3 plus 4/6. Okay. So 5 2s would be 10, 10 and 4, 14. So I'm changing my mixed numbers to improper fractions. So this would be 14 over 5 plus 3 1s 3 and 2, 5 over 3, 5/3 plus 4/6. Now I need the LCM of 5, 3, and 6. I want you to think about that for a little bit. Think about it, what it could be. Any ideas? All right. So if you came up with 30, then you should be good to go. But let's say you did not readily think of 30. We could put this into our little ladder and work our way down. 2 into 5, we're going to have a remainder, so we write it back. 2 into 3, same thing, we write it back. 2 into 6, 3 times. We have no more even numbers, so we can move on to the next smallest prime, which is 3. 3 into 5, we're going to have a remainder, write it back. 3 into 3, 1, 3 into 3, 1. The aim is to get everything to 1. Moving, next prime would be 5, 1, 1, 1. Draw your what? L. We're going to write LCM being equal to and multiply everything. 1 times 1 is 1, 1 times 1 is 1, 1 times 5 is 5. 5 threes would be 15, and 15 times 2 would give us 30, which is what we have here. So now we're going to be making what? Equivalent fractions, all of them with the same denominator. So 5 into 30 would go 6 5s 30. Now 6 times 14, so we have our 14 here by 6. 6 fours would be 24, right? 4 carry 2, 6 ones, 6 and 2, 8. So we get 84. 84 plus 3 into 30 would be 10 times. Use that factor and multiply the numerator. So 10 times 5 would be 50 plus 6 into 30 5 times, and 5 times 4 would be 20. Now we're going to end up with 20 and 50 being 70, and we have 84 and or 74. 8 and 7 would give us 15. Okay, so we end up with 154 over 30. How many times could 30 go into 154? So I know that 5 could go about 3 times. So let's go with this. So if I have 30 and I go 5 times, this is 150, remainder 4. So let's look. I have 5 whole times and 4 over 30. But we could take this down somewhere because I could use 2 for the numerator and 2 into 30. So I could get 5 and 2/15. All right, so that's one way of looking at the problem. Let me see if we could look at this in another way. So that's using the approach where we're changing our mixed numbers to improper fractions, and we work from there. That usually works out with us having larger numbers to work with. I'm working with the largest number here being what? 154. Let's deal with the whole numbers first. So 2 and 1, we're going to add those. So 2 plus 1 would be equal to 3. So I have 3. Now I'm going to work with 4/5 plus 2/3 plus 4/6. Again, LCM here would be 30. 5 into 30 would go 6 times 6 4 is 24. Plus 3 into 30, 10. 10 times 2 would be 20. 6 into 30, 5 times 5 fours would give us 20. So 20 and 20 would give us 40. 40 and 24 would give us 64 over 30. So this is 3 plus 64 over 30. Now 30, let's just look at this section of it. 30 could go into 64 two whole times. Okay, so this can be converted to 2 and 4 over 30. So if we add our 3 and 2 as whole numbers, we're going to get 5. And then we end up with 4 over 30. This begins to look familiar, right? All right. Now we can reduce, because the highest common factor of 4 and 30 would be 2. And 2 can go into the 4 2 times, and 2 can go into 30 15 times. We end up with 5 and 2/15. Now, some people prefer this method, the one that we used last here, because the largest number I'm working with here is 64. However, if at all you forget about your whole numbers, you have to pay special attention to them, you might end up with an answer that is wrong. All right. So you have two ways you can get there. Doesn't matter which way you choose, as long as you get to the right answer. Whichever one works best for you, choose that method and get it done. What is the LCM of 8, 3, and 6? Again, easy. 8, 3, 6. Using our ladder method for prime factorization, let's start with 2, 2 into 8, 4, 2 into 3. We're going to write this back because we can't go into it without a remainder. 2 into 6, 3. Use 2 again because we have 4. So 2 into 4, 2 times. And we write back these 3's because we can't go into them equally or exactly. 2 into 2, 1. Write back our 3's. Now we go to 3. 1, 1, 1. We're going to draw our L, multiply everything. 1 times 3, 3. 3 twos, 6. 6 twos, 12. 12 twos. The LCM is equal to 24. 8 can go into 24. 3 can go into 24. And 6 can go into 24. So our answer is 24. What is 0.8 squared? 0.8 squared. And squared means that we're multiplying the number by itself. So 8 eighths will give us 64. How many places of decimal do we have? We have one place here. We have another decimal place. So our answer should have 2 decimal places. So we'll go 1, 2. My answer should be 0.64. Right. So just remember, in this one, we need to remember squared numbers. We need to remember what they are, how we get squared numbers. We're going to multiply the same factor, the factor by itself. We need to remember how to multiply decimals, counting off the decimal places, multiplying as if there are whole numbers, going back at the end and putting in the decimal points as needed. What is 746 in exponential form? So let's break this 700 first into expanded form. 700 plus 40 plus 6. 700, this would be 7 times 10 to the second power. Notice the number of zeros, 2 zeros. Okay. This is plus 7 times 10 to the first power plus 6 times 10 to the 0 power or 1. Okay. So in exponential form, it should be 7 times 10 squared plus 7 times 10 to the first power plus 6 times 10 to to 0 power. So let me go back a little bit. So please, easy way, you look at it. We know that this 700 is really what? 7 times 100. Okay, and 100 is 10 square. And 7 times, no, haha, I made a mistake. Let's go back. This is not 7. This should be 4. Always good to check your work, huh? So let's go back. So this is 4. That's too far away. Let me write this one in. This is 4 times 10, giving us 40. All right. Said the wrong thing there. So let's fix this. And 40 would actually be 4 times 10. And 10 is 10 to the first. We're using the base once. And this would be 6 times 1. And that's represented by 10 to the 0 power, which is 1. Okay? All right, so that one is nice and correct now. Tell the face value, place value, and true value of each number. So 5 is in the ones place. So the face value is 5, the place value is 1, and the true value would be 5 times 1 being 5. The 8, and this would be our ones place. So in our tens place, it would be 8. And this is, all right, let's put this in. Face value, place value, and true value. Face value is 8. 8 times 10 would give you 80. Then we move on to our hundreds place. All right. So we have 9 face value, place value 100, 9 times 100, true value 900. Finally, we have our thousands place, and in the thousands place we have 3 face value, place value thousands. 3 times 1,000 would give us 3,000. So this is why we end up with 3,000 plus 900. No, let's make this neater. Make it closer to 900 plus 80 plus 5. And we end up with 3,985. So that's the face value, the place value, and the true value. How do the face value? We call the number by its name. The place value is whether it is in the units, the tens, the hundreds, the thousands, the tens of thousands, the hundreds of thousands, whatever place it occupies in the number. And the true value is found by multiplying the face value by the place value. And the result is what we call the true value of the digit. It says which pair is equivalent. So we have 4 pairs here. We have, let's say this is A, this is B, this is C, and this is D. So to find out if they're equivalent, we're going to reduce. Can these be reduced? 16, 100. 2 into 16 goes 8 times. 2 into 100, 50 times. Okay, 2 into 8, 4. And 2 into 50, 25. I end up with 4 over 25. If I really wanted to, I could have said the highest common factor of 16 and 100 would be 4. 4 into 16, 4 times, and 4 into 100, 25 times. But we start with 2, and we can work our way down if you don't readily see the highest common factor. Okay, let's look at 8 tenths and 80 over 1,000. I could say 0 cancels 0, which is the same as saying the numerator divided by 10 and the denominator divided by 10. I end up with 8 over 100. So if this is equal to 8 over 100, again, I could say 4 into 8 goes 2 times. 4 into 100 goes 25 times. I end up with 2 over 25. Now, 8 tenths and 2 over 25, not equivalent. 6 tenths and 4 over 25, not equivalent. We have 9 tenths and 90 over 100. We could say 0 cancels 0. Automatically, I see that we seem to be equal here. Let's check the last one. We have 16 over 100 and 16 over 1,000. Okay, so 4 into 16 would go 4 times. 4 into 100 goes 25 times. 4 into 16 goes 4. 4 into 1,000 goes 250 times. Not equivalent. However, see, when we reduce 9 tenths and 90 over 100, I get 9 tenths on both sides. The highest common factor of the 9 and the 10 would be 1. So this is in simplest or lowest terms. We can go no further. So 9 tenths is equivalent to 9 tenths. What does that mean though? It means that the same value exists for both fractions, even though they are called by different names. So it is the same value, but different names. How many things are in a score? Okay, 20 things are in the score. In a dozen, 12. In a century, 100. In a decade, 10 years. In a month, 30 days or 31 days or 4 weeks. In a year, 365 and a quarter or 366 if it's a leap year. In a minute, we have 60 what seconds, 366 days for the leap year, and the millennium is a period of 1,000 years. So let's try to remember those. Hold on, we could do one more. Our gross is made up of 12 dozens or 144 units or items. Okay, here we have a situation where we're looking at football, tennis, and swimming. Who plays tennis and also swims? So we have tennis and swimming. So we have tennis here. No, this is swimming and tennis. So we have Karen. Karen is both in swimming and tennis. So for number 1, no. Who plays football, tennis, and also swims? So we're looking at Karen because Karen plays both tennis and swims and plays football. So Karen is the intersection of all 3 sets here. So who plays football? Person must play football, person must play tennis, and the person must swim. So tennis, yes. Swimming, yes. Football, yes. Our answer would be Karen. How many individuals here play tennis only? So let's look at tennis. So you have only tennis. These play both tennis and something else. In Paul's case, Paul likes tennis and football. In Karen's case, Karen likes all of them. But these people only play this particular sport. So how many? Jen, Kay, and Joan. So 1, 2, 3. So we have 3 persons here who play tennis only, 1 person who does swimming only, 2 persons who do football only. If 6 mangoes cost the same as 12 plums, how many plums cost the same as 24 mangoes? So this is a ratio. We have mangoes here, and mangoes are being compared with plums. Okay. So 6 mangoes, 6 to 12. And then we need to find out how many plums. This is where our question is. In this case, let's use n. How many plums are the same as 24 mangoes? All right. So what did they do? Let's use 2 approaches. Let's use the common sense approach. What did they do to 12? What did they do to 6 rather to get it to 24? They multiplied this by 4. 6 fours would give you 24. So we could say 12 times the 4 would give us what? 48. Okay. So tentatively, we can put down 48 and say that it should be 48 plums would be give us the same as 24 mangoes. Hold on to that thought. We're going to now work this out in another way. So let's take these out. And we're going to cross multiply. Hold, running too far. So we're going to say 6 times n. This would give us 6n on one side of our equation, and 12 times 24 on the other side of the equation. Let's look at 24, and we're going to multiply that by 12. 2 times 4, 8. 2 twos, 4. Placeholder 1 times 4, 4. 1 times 2, 2. Add these, we get 8, 8, 2, 288. Now, if we need to find out, if we need to get n by itself here, we'll divide this side by 6. We'll divide this side also by 6. Whatever I do to one side of the equation, I need to do to the other side of the equation. So 6 divided by 6, 6 will cancel 6, leaving me with n. And then now I would say 6 into 28 would go 4 whole times, because 6 fours would be 24, remainder 4, and 6 into 48, 6 eighths would give me 48. So n is equal to 48. So either way, we end up with 48 being our answer. Hold on, give me a second. Let me check something. All right, let's look at this also. If it is that this is going to be balanced, then we should have 6 over 12 and 24 over 48, and 6 into itself one time, 6 into 12, 2, 24 into itself one time, and 24 into 48 2 times. A half is equal to a half. We again see that this is balanced. Therefore, we know that that is correct. Five bags and 1 pair of shoes costs $4,700. If one bag costs $700, what is the cost of the pair of shoes? So 5 bags, 1 pair of shoes cost 4,700, and one of the bags costs 7, and we have 5 of them. So it would be 5 times the 700 this would give us what? 3,500. So the cost of the bags would be 3,500, and we have 7. The total would be 4,700. So we need to know what the cost of the shoes is. We could subtract 4,700, and we can, that's not 4,700, 4,700, and we can now take the 3,500 from that, and we'll find the cost of the pair of shoes. 0 from 0, 0, 0 from 0, 0, and 5 from 7 would be 2, because 2 and 5 makes 7, and 3 from 4 would be 1. So the shoes should be 1,200. Let's check to see if this is correct. So 5 pairs, or 5 bags rather, and 1 shoes should be equal to $4,700. So we have bag plus shoes should be equal to 4,700. Bags, 500 for one, sorry, 700 for one, and we have 5 of them. So let's see, 700, and we multiply that by 50075 is 35. We had that before. So the bags would be 3,500. We worked this out, and we said that 1,200 would be the shoes, and we should get 4,700. Let's see, 3,500, and we're adding to that 1,200, 0,074. We have 4,700 being equal to 4,700, and we know that we're good. All right. What is used to measure length? It's not milligram. Grams have to do with weight, not liter. Liter has to do with volume, not meter. Meter has to do with distance. So, no. Length, yes. Distance. That's what we're looking for. The kilogram is used as a distance of... A kilogram is not used to measure distance, but used for weight. So this one is also out. Let's swap colors. So this one is out. But the kilometer is used to measure length. So that one is correct. So let's go over that again. The units here, milligram, we use that for weight. Milliliter would be used for volume. Kilogram, it's another version of this. So it's also used for weight. But the meter is used to measure distance. We haven't touched this unit yet, but this is our unit on measurement. All right? So you can read up on that until we start doing those questions. The prefix, again, one from measurement. So centi, and we did some of this in language arts. Centi would be 100, deca, 10, milli, 1 thousandths, and kilo, 1,000. All right. This. So centi, 100, deca, 10, milli, 1,000, kilo, 1,000. All right, guys, that's it for now. We will see each other in next episode. Keep remembering that mathematics is not magic. Mathematics is logic, and we are all capable of getting a good grade. All right, see you guys later.